Welcome back at the Syllable Summerconference 2011. We have about an hour left, so we'll hurry a bit with the presentations. We're still viewing the program for today. I've told a lot about the new Red programming language already. I was discussing the five bindings to existing libraries that I've made so far. Most of them are still in development, so the functionality is now partly available from Red. A library that's not mentioned in our program is a binding to the C standard library, because that's the base for almost all programs. So what you have to keep in mind is that most of the programs that I make in Red now are based on a binding with the C standard library, and that binding is actually quite complete. I have bound the entire functional set of the standard C library at the NCC level. So there are many more functions in industry standard C libraries, such as the GNU C library. But what I've bound is a very portable subset that's defined in NCC. And that's quite complete. It's just that the math library, which is more or less separate, I have written the binding, but it doesn't work yet in Red System because Red System doesn't support floating point values yet. But at the moment that Red System or Red will support floating point, that part of the binding will also start working. So it's basically complete at the NC level, and the other programs you will see are mostly based on it. So that leaves 4 other bindings, and I just told about the 0MQ binding, which I've done in 3 versions for Rebel 3, Rebel 2 and Red. And because 0MQ is cross-language and cross-platform and cross-network, you can now message between these 3 languages and other languages that 0MQ has bindings for. 0MQ has bindings for about 20 more languages. So you can, if you want to write Python or C++ programs and you want to have another program in Red, for example, because you have a C++ library and you have a Python program that you already did, and you want to write a new part in Red, then you can integrate them by having them send messages to each other through 0MQ. And you're free to do that within one local system or with just a few configuration changes across a network. So that's very nice about 0MQ. The other bindings aren't even mentioned here in the program because I wasn't sure I would be able to get them working before the conference. So I can now add to the program a binding for SDL that I did, and those are the bindings that are not complete yet. SDL in full is a rather large library, even though it is the simple direct media layer. It's a very thin layer on top of other operating systems to provide a cross-platform multimedia framework that's used a lot for games and things like it, especially open source games, but also commercial games. The thing is, if you take Rebel as a reference, there are 2 main versions of Rebel. There's Rebel Core, which is running in the command line in text mode, and there's Rebel View, which has a graphics engine. And on top of Rebel View is a VID, Rebel domain-specific dialect for creating user interfaces. So the red that Nenat is currently developing, it's just a language, so it is a compiler that runs in the command line and programs that currently run in the command line. So I have made the next step with my SDL binding to give it a graphics engine. And of course Rebel is extremely cross-platform, I may say. So you also want a graphics engine to be very cross-platform. And the thing you would automatically choose nowadays is to use SDL as a binding for a very cross-platform graphics engine, or an interface layer to graphics engines, because it provides the same framework on many different operating systems. And because SDL is so portable, we also have it in Syllable Desktop. So by writing an SDL binding for Red, I now have a graphics engine that works on Syllable Desktop and many other systems when you compile the binding for them. So I can demonstrate SDL programs running on Syllable Desktop and on Syllable Server, for example. And they could also run on Windows or on Mac OS, only you have to install SDL as an extra there, because it's not included in Windows, and maybe SDL could be included in OS X, I don't know. It's possible. Or otherwise there are systems that you can install it through, and on Windows you will just have to copy some loose files, and then you'll also have SDL available. So the installation is easier on Syllable systems because they already include SDL, but the program can run without modifications as a graphical program on very many systems. Then the very latest, which I only did last week, I already said, SDL is just a graphics engine. You get colored dots on your screen. But you don't get a graphical user interface, so you don't get widgets such as buttons and menus and text entry fields. That's a GUI, and that's on top of a graphics engine. And if you look at the Rebel design, Rebel has its own domain-specific dialect for a GUI that runs on top of its own graphics engine. So I don't have that yet, I have them separately, because I have this binding with SDL that gives you a graphics engine where you can do drawing, whatever you want, but the SDL does not have a GUI. And there are GUIs on top of SDL, but they are primitive. They are mostly for programming games, so they have some simple widgets that you would need in games, but they're not as comprehensive as a real popular GUI framework such as GTK or Qt, the two most popular GUI frameworks on Linux and other open source systems that run on X11 anyway. But what I've done last week is a binding with GTK, and that deserves some explanation. Syllable is immediately relevant, SDL is immediately relevant to Syllable. GTK is not obviously relevant, except that if you know that for the past year or year and a half almost, we have had in-house a graphical version of Syllable Server. So it's messy because we're using Gobo Linux, where we've put Gobo Linux on top of Syllable Server, and that gives us an X11 environment with GTK and other toolkits and a lot of extra software. And the integration is messy, so we can't release it in this way. So we haven't released this graphical version of Syllable Server, but we are using it internally. And that means that I am using a graphical version of Syllable Server, including GTK. And I also have a few Qt programs running. Now the choice for Qt, for GTK, Uh, if you want to bind a language to a library, the way to do that is through C-level interfaces. If a library doesn't provide a C-level interface, then you have a problem with binding it. And if a language does not have good support for C-level bindings with interfaces, then you also have a problem. And many higher level programming languages have problems binding to external libraries because it's difficult to bind higher level languages to C level and assembler level system libraries. In Red, this is solved by Red System because Red System is C level, and so Red System has excellent support for binding C interfaces in other libraries. The other side is that if a library does not offer a C interface, you have a problem on the other side. And that happens when you write the library in a different language than C, one of those languages that does not have good support for C interfaces. And now the thing is that this applies to C++. If you write a library in C++ and you do not define special interfaces beyond the objects that you are programming your library in, then you only have a C++ object interface. And this is not very easy to bind to other languages, including Red, because a C++ object interface is not automatically a C interface. And I will step back to ZeroMQ here for a while, because the interesting thing about ZeroMQ is that it's written in C++, but it's also easily bindable to many languages. And they do that by not writing the interface in C++. The fact that ZeroMQ is written in C++ is not visible from the outside, because ZeroMQ has an interface that is defined at the C level. And you don't automatically get that by writing a library in C++. It's an extra. You have to make an extra effort to give your C++ library or program a C-level interface. Hardly any C++ frameworks do this, and that's why C++ frameworks are generally hard to bind to other languages. And if you look at Qt versus GTK, for example, these things become very clear, because GTK has traditionally had more language bindings than Qt, and if you want more language bindings in Qt, which is written in C++, you have to make a lot more effort than for bindings in GTK. So ZeroMQ is very nice. It's written in C++, but it doesn't have to concern us. It has a C interface, and therefore it has bindings to more than 20 languages. And I have added the bindings to the Rebel family of languages, including Red, because Red is very good at binding C code. So there's no problem there. If you try to bind Qt, written in C++, to Red, you have a problem, because Red can do C interfaces, but Qt doesn't really, because it offers C++ object interfaces. And you have to write actually two bindings. You have to write the Red binding on the Red side, and you have to write a separate C++ binding on the C++ Qt side to bind. You have to implement a C interface to your C++ library first before you can bind it to a higher level language, or even a low level language such as Red System. So this is a double work for C++ libraries such as Qt. So the thing is, if you start looking for a GUI library that you can bind in Red, you are looking for C libraries if you don't want to do double work. And this double work is not one time when you bind it, but every time a framework or a library is changed, you will have to track those changes in your binding. So if you want to bind to C++ libraries, you have to write two bindings, one for Red and one for C++, that meet in the middle in a C-level interface, and then you have to maintain both sides, including the C++ side, for any change in the C++ library. So it's really double work, plus you will need to have someone who is knowledgeable about C interfaces, knowledgeable about Red, to write the Red side of the binding, and knowledgeable about C++ to write the C++ side of the binding. And in Syllable we already have a huge problem getting people to write Syllable applications in C++. So we can't really afford to do double work in bindings. So that's why you more or less automatically arrive at GTK if you want to build, if you want to bind Red to a popular open source GUI library. Most of them are C++, so that's double work, we don't want to do that. And only a few of them are C, and GTK is clearly the popular one. So that's why I chose GTK for the cross-platform binding for open source systems such as Linux and BSD. And GTK also runs on Windows and OS X, although it's less well supported there. But if you want to be able to write GUI programs in Red for open source systems, then GTK is a more or less automatic choice, it turns out. So last week I've made a beginning of a GTK binding, and also GTK is even much larger than SDL, so it's by far not finished yet.
Did you consider VX widgets?
Yeah, but it's also written in C++, isn't it?
Okay.
So I evaluated many GUI libraries over the last more than 10 years. So for this binding I revisited many of them to see how well they fitted with Red. And then I saw very clearly that almost all of them are C++. And that's really a problem. You can write C++ programs for a C++ GUI, that's no problem because it interfaces right away. But any other language than C++ has a serious problem binding to a C++ library. And as you know, Syllable's high-level libraries are also C++. So binding to Syllable is also a problem for all languages, but also for Red system, even if it can bind very well to C code. And we have talked about this for 10 years. One of the main things we always talked about is how do we get language bindings, because the only way to write graphical Syllable programs is still C++. And we have always wanted bindings with other languages, and I have always pointed to Rebel as a language that would make that less difficult. And that now shifts to Red, which really makes it easy to write C bindings, but you still have the problem that you're trying to bind to C++ systems. Okay, so 0MQ binding, underlying C binding, SDL binding, GTK binding. I had one more. What was that? I even forgot which bindings I did. There's another one. Bosh, which bindings did I do?
Recall them? What you just said?
Yeah, C, 0MQ, GTK, SDL. Oh yeah, curl, of course.
Yeah.
Was one of the first. Curl is the library, the third-party library we use in Syllable as its networking library. And if you look at it this way, many libraries in open source are still written in C. And it's becoming ever clearer to me why that is, because it's easy to bind. It's simple to implement because C is simpler than C++, but you can argue about that, but you can't really argue about the fact that C libraries are easy to bind, and C++ libraries are only easy to bind if you implement an extra C interface. And hardly anybody is doing that except our example 0MQ. So if you don't get a C interface with your C++ library, you have a problem. So curl is easy to bind at C, and SDL is easy to bind at C. GTK is easy to bind at C, and of course the C library itself. And 0MQ is easy to bind because it's C++, but the interface is defined in C level. And you can write a C level interface in C++, but you have to make an extra effort to do that, which really makes things a lot simpler. So that's the background on bindings. And then we have a few extra items in our program. We discussed a bit of it already. Early this year, before Red popped up, when I still had time for other things, I did a series of work on our infrastructure and my content management system that all our sites are built with. We are using the Cheyenne web server, but it's fast, but not as fast as it can be, and it doesn't have all the features that you want in a professional web server setup. And Nginx is going very well, has reached 1.0, and even has a commercial support company now. So what many people are doing, and what I'm following in now, I've switched Nginx in front of Cheyenne as a proxy server. And then you can really start looking at what one web server can do better than the other. And Nginx is a static web server, it does not do dynamic content. So, and Cheyenne, that's where we run Rebel and my Rebel content management systems. So Cheyenne is really where I do my dynamic content. So I've changed the infrastructure that the websites are now running on Nginx, and Nginx is all serving all the static content such as images and static pages. And for anything that's dynamic, it is proxying to Cheyenne as a backend web server. And that makes our web infrastructure faster and more scalable and more flexible, because I have more flexible rewrite rules and features like that. So that's a bit of background on our infrastructure, and that's also the kind of stuff I'm using personally, because we simply need that even beyond Syllable. But we have all that running on Syllable servers, so my requirement that everything should be able to run on Syllable is fulfilled by having all our web infrastructure running on Syllable server. And then the next item is Fossil, and that's very interesting. I found that less than a year ago. We have also been looking for almost 10 years for a good distributed software source version control system. And yeah, it's a long story, but I used to want to use Arch, but Arch failed somewhere along the way. The project was brilliant, but it was abandoned halfway. And after that I didn't know what source control system we should use. And the last few, in the meantime Subversion was popular, but it's not distributed, and I really wanted a distributed system. Nobody understood that 5 years ago, and everybody wanted us to switch to Subversion. But now everyone says Subversion is old, and everyone wants us to switch to Git because it's distributed. And I said, yeah, 5 years ago I wanted you to switch to distributed. So everyone is doing distributed now, but everyone now wants you to switch to Git, which is sorry, but it's a huge pile of crap. I've tried to port it to Syllable, and maybe with a lot of effort in the newest versions it's possible now, but Git has a huge number of dependencies, and if you want to put Git on Syllable, you drag in Perl and Python and a whole lot of libraries, and maybe even TCL for some extra utilities, and then you still don't have a lot of basic functionality. So I was still looking for a much leaner and easier to handle distributed version control system, and less than half a year ago I found it, and this is Fossil. This is my own short manual about fossil and how to use it, especially on Syllable. This is the fossil site itself. And the fossil has many interesting properties. It's very small, it's self-contained, it's written in C. So if you wanted to, you could rip it apart and bind to it. But it's self-contained executable, very easy to manage. It has lots of features that Git doesn't have and that you need services such as GitHub for. Everyone wants you to switch to GitHub now, and Red is there because GitHub is popular. But in Syllable we want something much leaner and more elegant. And Fossil has many features built in that you have to get from GitHub because Git itself doesn't have them. And one of the interesting things is that Git has the web viewer built in. Fossil communicates through its built-in web server. The whole Fossil communication is based on the web protocol, which also means that it's easy to get it through firewalls, and it means that you can even run a website on it. This is the...
But Git also has that?
No, it's extra. You have to
I
forget.
thought you just said something like that.
Yeah, I think I swapped Fossil and Git
Okay.
a while ago. So the thing is, lots of extras that you get in Fossil are extras in Git. So you have to add extra parts, and those are written in other languages, so you have to add other languages. So you have a huge amount of dependencies, and for Syllable we would have to port all of them to Syllable, and that's always a problem. So this is the Fossil website, and this website is actually being served by Fossil itself, because Fossil has a built-in web server. And the content of the website is also in the Fossil repository, and because the website content is in there, it's also automatically versioned.
Is the web server static? Serving static?
No. It's very dynamic, because every Fossil is a source control system, so it's a database, and it's distributed, so it's a distributed database. And not only that, it's a distributed, versioned database, like it says.
But could you use the Fossil web server for simple websites?
This is a not even simple website in Fossil.
Yeah, but I mean there are no rare restrictions.
Well, the point is, if you want to do dynamic websites, you need to program them.
Yeah.
So you need a programming language, and we want to do that with Rebel or with Red now preferably. And there is no Rebel or Red in Fossil. So its own web content is programmed in its own language, and Fossil itself is written in C and SQL, what they want to call SQL. And there's also utilities for Fossil are written in TCL, which is rather quite Rebel-like. So the philosophy of Fossil is quite the same as Syllable and Rebel. It uses a small, compact, self-contained, elegant system with everything included. It's written in a simple programming language C, but it also uses high-level dialects, SQL, and it does tools in a nice dynamic programming language in TCL, quite like Rebel. So philosophically it fits, it's just that the parts are a bit different. It would be even better if it were written in Red, but okay, it's really a lot better than Git. And it has very nice features. Here's the timeline of Fossil itself. That is where you get version control, and here you can see how a project develops. So you have lines of development here, and you can branch those lines, so you get a fork, and later you can merge those branches together again. That's what you do in a version control, in a modern version control system. And if you want to do that distributed, especially to fit the open source community. So this is a distributed system like Arch and Git and many others these days. And here you get the overview of what everyone has done in their own Fossil repositories, which have been merged together in this master repository. And there isn't a real master. A master is just a database that you appoint. There is no real master. You can appoint any database as the
It's
master.
pure peer-to-peer.
Yeah, and actually there are 3 repositories for Fossil itself, running on different servers. So if you nuke half of the United States, I should say God forbid, but there are probably some people who would want to do that. But if you would nuke half of the United States, there would still be 1 or 2 other servers in the other half of the states, or maybe even on another continent. And they synchronize their data with each other. So if you contribute to Fossil itself, you can merge your contributions with any of those 3 master servers, and they will sync it with each other again. So it's a really replicated system, very distributed, very flexible. And this is what I was looking for, because I am an old Lotus Notes specialist and I was looking for a Lotus Notes style database, and this is it.
Wasn't it also developed by the US Army?
Fossil?
Yeah.
Fossil is definitely not developed by the US Army. Fossil is developed by a lone open source, the guy who made SQLite, which is the base for Fossil, by the way.
Yeah, but wasn't he working for the US Navy or something?
Oh, it could be. He's a consultant doing assignments, so it could be that that's one of his customers.
Can Fossil be used as part of another bigger program, that you use it as a library or something?
It's not, because it's so self-contained. It's a self-contained executable. So there is no separate library, although internally there probably is. So maybe you could rip it apart because it's open source, but it's not meant for that. It's meant to run on its own as an executable, or even as a server.
As a service or something.
Yeah, and but the client and the server are the same program. Like Lotus Notes 1.0, they split that in Lotus Notes 2, so this really goes back to basics. Very nice, very elegant, and when it runs locally or as a server, you have an interface with it. If you run it locally, you have a command line interface, and if you run it as a server, you have an HTTP interface, because it communicates through its built-in web server.
But if you have a distributed set of programs running, or databases, I mean, can you automatically make them replicate each other?
Yes, they replicate. You only have to point to them and say you have to sync with that database, and it will do so when you say so.
And does it integrate nicely with that? I mean, does it...
Yeah, syncing is built in. The only thing where it lacks is in programmability, because it's not open to other programming languages than it already uses internally. It's not meant as a programming platform, so that's why I want to add, and that's not, it's not ideal, but it's way better than things such as Git. And this is what I originally wanted to use Arch for. So we can do a lot with this. Well, here's the timeline. This is a very nice overview of how development goes. So the first goal is to use it for what it's intended for, to slowly move the syllable source code into this. Now,